Hey guys, and welcome back. Today we're going to be looking at the rule with negative exponents. But before we do that, we want to keep in mind the three rules we've already learned. First of all, when you have the same base and you multiply across, you add your exponents. Power to a power, we multiply exponents. When we're dividing exponents, we subtract. Now whenever, I know we didn't specifically talk about this, but whenever you have any exponent taken to the power of 0, that's always going to be 1. And now we are looking at negative exponents. So it says negative exponents can be rewritten using positive exponents using the negative exponent rule. And I'll show you what happens with this. What we do is we take whatever that is and put it over 1 unless it's already a fraction, and you send it into the denominator. So you would have the 1 on top and x to the positive a, and I hope that looks like an a, on the bottom. Now if you're like me, that might not make much sense right now. But as we work through it, it's gonna make more sense to you. What I like to do is I like to write move. You have to move your exponent. I don't want to say that you always put it into the denominator, because sometimes you'll have negative exponents in the denominator. And in order to make those positive, you're going to have to put them into the numerator. So you're going to have to move them. If you don't already have a fraction, you're going to have to make a fraction. Sort of like in example 1. Let's check it out. So right now our base is x, and our exponent is -5. We can't have negative exponents. So we need to make it a fraction, since it's not already. And we need to move it. Since it's in the top, we send it to the bottom. We're gonna bring this guy down. Now my 1's only gonna be on top because it needs to hold the place. I'm not switching them, it's just that I need something to hold that placeholder. And then once I put it on the bottom, it becomes a positive. There's nothing else I can do to simplify here, and I'm done. Let's check this next one out. All right. I do see that the base of m has a negative exponent, so I'm going to make this guy a fraction. Now I'm going to take that negative exponent and throw it into the denominator. But my 3 does not have a negative exponent, so I don't need to move that. My 3 stays on top. I no longer need that 1 to keep my placeholder because my m is going to be on the bottom, and then that -2 turns to a positive exponent of 2. Let's look at this last one. All right, I'm gonna make this a fraction. I can see I have 1 negative exponent, it's right here. So that's the only thing I need to move. I'm gonna keep my -7 up top. The b to the 3rd is gonna stay on top. Now I could keep the 1 on the bottom, but there's really no need, it doesn't change anything. So I'm just gonna put my a to the +4 down there. And that one's simplified. Let's look at our next ones. With these next examples, we're going to have to remember all of these rules and apply them as needed. So it says simplify each expression. Make sure the final answers contain only positive exponents. Hint, use the rules, then move the variables at the end. See, move those variables if you must, only if they're negative. All right, let's check out this first example. The base is the same and we multiply across, we add our exponents. 7 plus -9 would give me a -2. So we have w to the -2nd power. We can't have that. We need to make that a positive. Let's move it to the bottom. We're going to keep the 1 on top just to keep a placeholder, and then w squared is going to go on the bottom. Let's try number 5. First thing I'm going to look at is we're multiplying our coefficients. They both don't have exponents, so 4 times 5 would give me 20. Next, we're going to multiply across, which means we're going to add our exponents. We have c to the 8th, c to the -5th. When I add those together, I get c cubed. D to the -3rd and d to the -1st. If I add those together, I'm going to get d to the -4th. All right, well, I've simplified as much as I could across, but now I have this negative exponent. I can't have that. That's not right. So I need to make a fraction, move that one piece. Remember, you're only moving the base with the exponent that's negative, not everything else that's attached to it. So I'm going to bring this guy down, and I'm going to rewrite it right over here. So I'll have 20c cubed on top. On the bottom, I'm going to have d to the 4th power. If you kept the 1 on the bottom, again, that wouldn't change anything and you wouldn't be wrong. It's just that it's unnecessary, so we usually don't write it. Let's continue looking at some of these examples. Make them a little bit bigger for ourselves. Alrighty, 6, 7, 8, and 9. I really enjoy exponents because you have to put a lot of different pieces together. Let's look at number 6. 6 times negative 3, notice that neither of them have exponents. 6 times negative 3 would give me negative 18. Got that guy? Got that guy. Next, x times x, we're going to add our exponents. Negative 8 plus negative 3 would give me negative 11. All right, well, I see a negative exponent, can't have that. I'm going to make this a fraction, move my negative exponent, and make it a positive. That negative 18 is going to stay on top. I can have negative numbers, I just can't have negative exponents. So that x to the positive 11 will be on the bottom. Let's look at number 7. All right, my coefficients for both of these are 1, so I'm not going to worry about that because 1 times 1 is 1. Let's find a similar basis and multiply across, adding our exponents. A to the negative 5th times a to the 7th give me a squared, because negative 5 plus 7 gives me 2. Once you get very long problems, and they will get longer, you're going to want to cross them off so that you know you've already addressed them. That's why I'm starting to do that now after I simplify. Let's look at our next basis, our b's. B to the 8th, b to the negative 3rd, 8 minus 3, or 8 plus negative 3, will give me b to the 5th power. C to the negative 12th, c to the 7th, negative 12 plus 7, give me c to the negative 5th. Uh-oh, so close to being done, but I can't have a negative exponent. That's okay, just move it. Put it over 1, send just that guy to the denominator, leaving my a squared, b to the 5th on top, that c to the 5th power is on the bottom, and we're done. Let's check out number 8. Alrighty, well, there are 2 bases in here. The first base is the 8 and the second base is the p. Remember, power to a power, we multiply. So I'm going to multiply both of those, giving me 8 to the negative 2nd power and p to the negative 10th power. Oh no, what do we do with this? Well, the first thing we do is we move it. We move it all. This guy's going down, and this guy is 2. So now we're going to have 1 over, I'm going to write this a little bit smaller, 8 squared, p to the positive 10th. See how my exponent became positive on the bottom? I'm still not done though, because I do want to simplify 8 squared, and I know 8 times 8 is 64. So I'll have 1 over 64 p to the 10th. Number 9, same type of situation here. We have 2 bases, I need to distribute to both of them. Power to a power, we multiply. So we have the base of 5. That's going to be taken to the power of negative 3. 2 times negative 3 is negative 6, so we have y to the negative 6th. I don't like negative exponents. I need to move them away. If they're on the top, on the bottom, I need to move them somewhere else. This guy's going down. This guy's going down. We have 1 on the top. Again, that's just keeping my placeholder for me since everything else is going to be in the denominator. Then I'll have 5 cubed y to the 6th. I do want to simplify the 5 cubed, and I believe that 5 cubed is 125. So I'll end up with 1 over 125 y to the 6th. Take a second and look at that, and we'll go through a couple more together. We have 10 through 15, and then 16 through 19 on the rest of the page, on the back. So let me scroll down. All right, they keep mixing it up as we go. We're gonna add a little bit, an extra rule here and there. I love it. All right, so let's look at number 10. We have 3 bases, which means we need to distribute that -4 exponent to all of them. Meaning we'll have 3 to the -4th power, r to the -4th power, because technically it's a 1 right now, and -3 times -4 gives me a +12. All right, I can't have negative exponents. I'm putting them over 1, and I'm gonna move 2 things. Move this guy and this guy. I still am gonna have s to the 12th on top, but on the bottom now, I'm gonna have 3 to the 4th power and r to the 4th power. Let me grab my calculator and see what that would give me. 81. So here again, we're gonna have s to the 12th power. 3 to the 4th power gives me 81. Then r to the 4th stays the same. And we're done. Very similarly, we have number 11. We're going to distribute that to everything, giving us 6 to the -2nd power, x to the -10th power, y to the +8, because negative times a negative gives me a positive. Next, we need to move whatever is negative. This guy's going down, as is this one. So on top, I still have my y to the 8th, but on the bottom, I have 6 squared, x to the 10th. I just want to simplify 6 squared, and I think 6 times 6 is 36. So I get y to the 8th on top, 36, x to the 10th on the bottom. All right, let's look at number 12 and 13. As you can see, they're incorporating that quotient rule that we know that when we divide, we need to subtract our exponents. So we do have the same base, so we're going to subtract our exponents. Our base is 8. 2 minus 5 gives me -3. Can't keep a negative exponent, make it a fraction, send it down there, move it. I'll have that 1 on top just to keep that place, and then 8 to the 3rd becomes positive on the bottom. Same thing here. We have common bases with the C's and the D's. So let's start with the C's. So -2 minus 7, and if you need to write it out, please do. I sometimes do, just to show you this. -2 minus 7 gives me -9. For the D's, I have -1 minus 2. Ooh, excuse me. -1 minus -2. That's why I write it out. -1 minus -2. What happens when we minus a negative? We plus a positive. -1 plus 2 is a +1. So we're going to have d to the 1st power, or just d. Well, I'm not quite done yet. I need to move this negative exponent. I'm going to throw that guy over 1, send him into the denominator, leaving me with d on top, c to the 9th on the bottom. All right, let's look at a couple more examples. Hopefully this is beginning to become fun for you. Once you start to understand it better, it definitely is more fun and entertaining. And usually students like a little challenge and they enjoy these. Alrighty, let's look at this one. We're going to first address our coefficients. 14 over 7 would simplify to +2 over 1, where 14 divided by 7 is 2. So that's going to give me 2. Next, 4 minus -2, because we're subtracting. So we have 4 minus -2. We know that when we subtract a negative, we add a positive. So we're going to get w to the 6th power. Now there's one other way of looking at this. So there's really no other way of looking at the 14 over 7. However, let me just rewrite it here. One thing that you could do is move your negative exponent first. Now it's all up to you. It's kind of like what you're more comfortable with. You're not going to get it wrong either way, but I'll show you how some students might solve this instead. They might say, hey, I know I can't have negative exponents, so I'm going to take this and move him up. When they move him up, he becomes w squared up top, and it'll become a positive. So that would leave me with 14 w to the 4th times, because if it's touching something, you know it's being multiplied, w squared. And then on the bottom, we still have the 7. We know 14 over 7 would still simplify to 2. But when we have the same base and we multiply across, we add our exponents, giving us w to the 6th. So just like before, we got the same answer. Let's look at this one. Negative 10 divided by 2 would give me negative 5. Now I'm going to subtract down. 2 minus 3 would give me negative 1. 1 minus negative 5 would give me a positive 6. I know I can't have a negative exponent, so I need to send him into the denominator, leaving me with negative 5 n to the 6th over n. All done with those. We got 4 more examples on the back here, very similar to what we were looking at before. Take a second and look at those, see what you can simplify on your own, and then we'll come back and see how you did.